Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Today going to proceed with the next chapter. The next chapter is periodic tables. There are two parts of periodic table. The first part is classifications of elements. In this classification of elements, we're going to specify periods, groups and blocks in the periodic tables. And the next objective, we're going to deduce the position of element in periodic table from the electronic configurations. Periodic table. Dmitry Mendeleev was a Russian chemist and inventor, and back in mid-19th century, he devised the periodic table which organized all the known elements. In fact, when he made it, he even predicted new elements that we hadn't discovered yet. All the known elements are arranged in order of increasing proton number. There are two main parts of periodic table. The first one, we call it the period, and the second one, we call it as a group. In periodic table, it can be divided into four main blocks. The left side of the periodic table, we have block. The right side of periodic table, we have P block. In the middle of periodic table, we have D block, and the last block that we have in the periodic table is F block. S block. First, we take a look at element in S block. S block element located in group number 1 and group number 2. From previous chapter, we already learned on how to write electronic configuration. Based on this electronic configuration, we can deduce position of element in the periodic table. For element in the S block, configurations of valence electron is ns1 to ns2. That one is a configurations of valence electron. Group number will determine by number of valence electron. Group number will be determined by number of valence electron. Period number determined by principal quantum number n of electron in the valence shell. For example, sodium, proton number for sodium is equal to 11. Therefore, electronic configuration for sodium 1s2, 2s2, 2p6 and 3s1. So from this electronic configuration, we can determine that configurations of valence electron will be equal to 3s1. Valence electron for sodium is 3s1. E will indicate period, S will indicate block, 1 valence electron here will indicate group. So from here, we can determine the positions of sodium. Sodium located at S block, group number 1, period number 3. Okay, let's take a look another example. So here we have calcium with a proton number 20. Therefore, electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So here we can see that the valence electron equal to 4s2. So means that from here we know that the period will be in the period number 4. Calcium in the block S indicate valence electron equal to numbers of. Therefore, calcium in the periodic tables locate at the S block group number 2 period number 4. Next, we take a look at the element in P block. P block element locate at number 13 to group number 18. Element in P block, configurations of valence electron for element in the P block is ns2, np1 to ns2, np6. Group number for any element in the periodic table, numbers of valence electron plus 10. Please remember that group number for any element in a periodic table will be equal to number of valence electron plus 10. Will be equal to principal quantum number n of electron in a valence shell. For example, let's see, here we have aluminium. Proton number for aluminium is 1s2, 6 to 3p1. So 3s2, 3p1 is a valence electron aluminium. Therefore, from here, these three indicate locate at the block P. Valence electron is 2 plus 1 plus 10. So means that it will in the group of 13. Therefore, aluminium locate at the P block, group 13, period number 3. Last one, D block. Element locate at the group number 3 to group number 12. D block element also known as a transition element. Element in D block, durations of valence electron will be equal to n minus 1 d1 and s2 to n minus 1 d10 and s2. So group number equal to numbers of valence electron. Number equal to principal quantum number of the electron in valence shell. Vanadium with a proton number of 23, S2, 2p6, 3s2, 3p6, 3d3, 4s2. Therefore, valence electron equal to 3d3, 4s2. Here will indicate block. 4 here, higher principal quantum number will indicate period. And valence electron is 3 plus 2 equal to 5. So group is equal to total of valence electron. Therefore, vanadium locate at D block group 5 period number 4. Thank you very much.